In this video, we're going to look at how you can take the equation of a hyperbola that may not necessarily be in standard form yet, how you can transform that equation into standard form, and then from there, identify the center, the vertices, and the foci. So here we have an equation of a hyperbola, 4x squared minus y squared equals 16. And you know that it's a hyperbola because the a value and the c value of your equation, if you remember talking about how to identify the type of conics, your a value and your c value are different signs. You have a positive and a negative on your x squared and your y squared. So you know that's a hyperbola. Okay, so what you want to do here, if you notice that you have an x squared and a y squared, but you don't have an x term and a y term, all you need to do in this type of problem is make sure that the right side of your equation equals 1. So in this case, you have a 16 over here. You need to make that a 1, so you're going to divide the whole equation by 16. Okay, so these are going to cancel and give you 1. This will reduce. 4/16 reduces to 1/4. So you have x squared over 4 minus y squared over 16 equals 1. Okay, so this right here is, this right here is your standard form equation. Okay, from there, can we find the center? Can we find the vertices? And can we find the foci? Okay, so the center is easy to identify. The center is your h and k values that you're subtracting from your x and your y. And since there's nothing being subtracted from your x and your y, your center is obviously at the origin, 0, 0. And you'll know that from the beginning because there's no x term or y term. There's an x squared term and a y squared term, but no x term or y term. Okay, to get your vertices, you need your a value because if you'll remember with a hyperbola, a is the distance from your center to your vertices. So remember that this right here is always your a squared value. This right here is always your b squared value. So if a squared is 4, that means your a value is 2. So the distance from your center to your vertex is going to be 2. The question is, in which direction do we need to move? Do we need to move up and down, or do we need to move left and right? And so you know that by the way your equation's set up. Because the x is first in this equation, that means we have a horizontal transverse axis. So we're going to move horizontally. Okay, so let's go ahead and label this so we can see it drawn out. Our center is at 0, 0. So from our center, we need to move left and right 2 units to get to our vertices. So we're going to move left 2. So we have a vertex here. And we're going to move right 2. So we have a vertex here. So our vertices are at 2, 0 and negative 2, 0. So sometimes we just write that as plus minus 2, 0. Okay, next we need to find our foci. And if you'll remember, to get to your foci, you have to know your c value. C is the distance from your center out to your foci. Your foci are going to be out here past your vertices somewhere because remember your branches are opening this way and your foci are out here somewhere inside that branch. Okay, so we've got to find our C value using our A and B value. We haven't written down our B value yet. Our B value would be the square root of this 16, which is 4. Okay, so we're going to use our little formula, C squared equals A squared plus B squared to find our C value. So C squared equals A squared, which was 4, B squared, which was 16. So C squared is 20. Square root that. C is the square root of 20. Okay, now this time we actually do want to branch out the square root of 20. We're not getting ready to put this back in the formula and square it or anything. So that square root is not going to get taken off. We do need to branch it out. So if you branch out 20, that branches into 4 and 5. 4 branches into 2 and 2. You get a pair of 2's. So that simplifies into 2 square root 5. So this is how far we need to go from our center. So from the center, we need to go 2 square root 5 units this way to get to our focus, and 2 square root 5 units this way to get to our focus. So basically what that's doing, it's taking our center point, 0, 0, and it's adjusting the x value of our center. Since we're moving horizontally, not vertically, it's taking the x value of our center and adjusting it by 2 square roots of 5. So the way we're going to write that is we're taking this 0 and we're going 2 square roots of 5 left and right. So it's plus minus 2 square root 5 and then 0. If our center value had not been 0, if our center value had been 3, for example, right here, then we would change our x value to 3 plus or minus 2 square root 5, comma 0. So whatever your center value is, you adjust it by whatever our c value is, to the right and to the left. So these are our 3 things that we were asked to find. Okay, so let's move on to one that doesn't necessarily have a center at the origin. Okay, so number 2, we have y squared minus x squared plus 12y plus 4x plus 31 equals 0. We know, again, that this is a hyperbola because our x squared and our y squared are 2 different signs. One's positive and one's negative. That's how you know that you're dealing with a hyperbola. Okay, this time our center is not at the origin, and you know that because in addition to the y squared, you have another y term. In addition to the x squared, you have another x term. So you know that you're not dealing with a hyperbola centered at the origin. Okay, to begin a problem like this one's a little more involved. You want to get all of your terms reordered. You're going to take your x squared or your y squared, whichever one is positive, and you're going to put it first. So our y squared is positive. You're going to bring the other y term behind it. Okay, so I'm going to do y squared plus 12y. And then I'm going to leave some space behind that. Okay, then I'm going to put my x squared, my negative squared term next. And then my other x term behind it. And then I'm going to leave some space. And then my constant term is going to go to the other side of the problem. So since it was a plus 31 when I bring it to the other side, it's going to be a minus 31. And I'm going to leave 2 spaces on this side. Okay. Now from here, what we're going to do is we're going to do something called complete the square. What we're trying to do is we're trying to create right here a perfect square trinomial, something that we can factor into the same 2 factors, into something squared. Okay, to do that, you take half of this term and you square it. Okay, so half of 12, and I'm going to jot it to the side, half of 12 is 6. When I square 6, I get 36. I'm going to put 36 in that space. Now to keep the equation balanced, whatever I did to one side, I have to do to the other. So over here in this space, I'm also going to put plus 36. Okay, now I'm going to do the same thing here also, but there is one problem. In order to complete the square, the leading coefficient on the squared term has to be a 1 first, a positive 1. Well, right now we have a negative 1. So before I complete the square right here, I'm going to pull that negative out. When I pull that negative out, that makes this positive x squared. That makes this a minus 4x, and then I'm going to leave a space. Okay, and that's an important step to remember. Before you complete the square, the squared term has to have a positive coefficient of 1. Okay, now I'm going to take half of this term. Half of negative 4 is negative 2, but when I square a negative, I get positive 4. So I'm going to put plus 4 here. Okay, now I have to balance the equation out, but even though I wrote plus 4 here, because of that negative out there, that negative gets distributed to everything in this set of parentheses. So even though I wrote plus 4, because of that negative, it's really a minus 4. So I'm keeping the equation balanced by putting a minus 4 over there. Okay, now I go to my factoring step. I want to factor this trinomial. The way I do that is I'm thinking, what factors of 36 can I add to give me 12? What factors of 36 can I add to give me 12? And that would be 6 and 6. So basically this trinomial factors into y plus 6, y plus 6, which is the same as writing y plus 6 squared, which is what we want. We want it to factor into the same two things twice so that we can put a square on it. Okay, same thing here. I want to factor this trinomial. What are the factors of positive 4 that will add to give me negative 4? And that would be negative 2, minus 2, minus 2. Okay, so that would be x minus 2 squared equals, okay, now if I add all of this up, negative 31 and positive 36 gives me 5, minus 4 gives me 1. Okay, so I look at my formula. I want to make sure this side is 1. As long as it's 1, I'm done. If it wasn't 1, then I would need to divide everything by whatever this number is so that it is 1. But it is 1, so that is my standard form equation for my hyperbola. Okay, so now that I have my standard form, can I give the center, can I give the vertices, and can I give the foci? So the center is always h and k. H is whatever's with x, k is whatever is with y. So my center is 2, negative 6. Remember the signs change because in your formula it's subtraction. So what am I subtracting from x? I'm subtracting 2. What am I subtracting from y? I'm subtracting a negative 6. That's what turns it positive. A y minus negative 6 would have made that a positive 6. So 2, negative 6 is my center. Okay, since I don't have any denominators under these two, that means they're understood ones. Okay, so that means my A is a 1 and my B is a 1. Okay, so that means to get to my vertices, I'm going 1 unit to get from my center to my vertex, 1 unit away. Now I need to know which direction I'm going. So because this is a y squared first, not an x squared first, I'm going vertically this time. Sometimes, again, it helps to kind of sketch it out. So if we were to draw this out, the center, let's see if I can draw it right here. The center is at 2, 1, 2, 3, 4, 5, 6. 2, negative 6. Right there would be the center. And then I need to go 1 unit up and 1 unit down because this is a vertical one. So 1 unit up would put a vertex there. 1 unit down would put a vertex here. So my vertices are at 2, negative 5 and 2, negative 7. 2, negative 5 and 2, negative 7. All right, so that means I'm opening this way and this way. Okay, so I have a focus somewhere in here and I have a focus somewhere down here. All right, so to figure out exactly where my foci are, I got to get my c value. So I'm going to do c squared equals a squared plus b squared. Well, 1 squared is 1 and 1 squared is 1. So I have c squared equals 2. Square root that. C is going to be the square root of 2. So I have to go the square root of 2 units away from my center to get to my focus. So from my center, I have to go the square root of 2 up and the square root of 2 down. Well, if I'm going up and down, which part of my center is affected? Is it my x value of my center that's affected, or is it my y value of my center that's affected? If I'm moving vertically, it's the y value of my center that's affected. So my foci are going to be at 2 and then negative 6 plus and minus this value, the square root of 2. And those are all the parts of that hyperbola. And one more, number 3. X squared minus 16y squared minus 2x plus 128y equals 271. Okay, so the same thing, you know you're dealing with a hyperbola because the signs on your x squared and your y squared are different. I have a positive x squared and I have a negative y squared. So I want to reorder everything starting with my positive squared term. So my x squared is positive this time, so I put it first. Then I put my other x term behind it, and then I leave a space. And then I go to my other squared term, which was the y. Next y term behind it. Then you've got the space. My constant's already on the other side, 271, and then I've got my 2 spaces where I'm going to balance the equation. Okay, so now let's complete the square. All right, so I come over here and I take half of this term. Half of negative 2 is negative 1, and I'm going to square that. When you square negative 1, you get positive 1, so I'm going to put plus 1 there, and then I'm going to balance the equation by putting a plus 1 over there. Okay, now when I complete the square on my y's, remember I can't complete the square until the leading coefficient on my squared term is a 1. So before I do this, I've got to get that negative 16 out. So we're going to pull the negative 16 out, which makes this y squared minus 8y, and then leave a space to complete the square there. Okay, so now we're going to complete the square here. Take half of negative 8. Half of negative 8 is negative 4. Square negative 4, you get 16. So I'm going to put plus 16 here. But when I go over here to balance the equation, it's not a plus 16. I wrote plus 16, but because that plus 16 gets multiplied by this negative 16 that's out here, it's really a negative 256 that balances the equation. So negative 256 is what I need to add to the other side. Okay, now I'm ready to factor. So I factor this. What are the factors of 1 that add to give me negative 2? And that would be negative 1 and negative 1. So this would factor into x minus 1 squared. Okay, then you bring down your minus 16 right here. And then I'm going to factor this. What are the factors of 16 that will give me negative 8? And that would be negative 4 and negative 4. So this would be y minus 4 squared equals, and then we need to combine all this together. So you have 271 plus 1, that would be 278, minus 256, so that would be 16. And one thing I want to mention here before we go any further, if you'll notice when you factor your trinomials, the number that you get right here when you factor is always whatever this number was when you took half of it. That's why I've been writing it down over here so you can see the shortcut. When we took half of negative 2 and squared it, half of negative 2 was negative 1. That's what it factored into. Half of negative 8 was negative 4. That's what it factored into, negative 4. Same thing up here in the last problem. Half of 12 was 6. It factored into a plus 6. Half of negative 4 was negative 2, and it factored into a minus 2. That's the shortcut. Okay, so now we're ready to simplify a little bit. Here's our equation. Remember, the right side needs to be a 1, so we need to divide everything by 16 to get that to be a 1. Okay, so we have x minus 1 squared over 16 minus, okay, these two 16s are going to cancel, so we just have y minus 4 squared equals, and then those cancel and we get 1. So this right here is the standard form equation. Okay, so now we need to know what's the center, what are the vertices, and what are the foci. So the center, remember, is HK, whatever's with X, whatever's with Y. So with X, we have minus 1, so that would be 1. With y we have minus 4, so that would be 4. So the center is at 1, 4. Okay, for your vertices, we need our a value. A is always under the first fraction. Since it's 16, the square root of that is 4, so a is 4. So we're going to move 4 units to get to our vertices. The question is, which way do we need to move? Well, in our standard form, our x came first, so this is a horizontal transverse axis. If you were to draw this out, let's see here if I can try to sketch it. Right there's your center at 1, 4. We know that we have a horizontal transverse axis because of the x being first. We need to go 4 units right and 4 units left. So 1, 2, 3, 4. There's a vertex, so that would be at 5, 4. And then we need to go 1, 2, 3, 4 over here. That would be at -3, 4. So you have vertices at 5, 4 and -3, 4. So your graph's going to do this number, open left and right. Okay, now you need your foci. So somewhere out here you have a focus, and then somewhere over here you have a focus. We need our c value. Since there's nothing under this fraction, you know your b's a 1. Okay, we need our c value. Let's work it out over here. C squared equals a squared. A squared is 16. B squared would be 1. So c squared is 17. C would be the square root of 17. And that doesn't simplify or anything, so we're just going to use the square root of 17. So we need to go the square root of 17 units out from our center this way and out from our center this way. Because we're moving left and right, what part of our center does that affect? Our x or our y? It affects the x. Anytime you move horizontally, it affects the x of your center or the h of your center. So we're going to take our center point and we're going to say 1 plus or minus the square root of 17. And then we're going to keep our y value the same. It's going to stay at 4 on the y-axis. And those are the parts of that hyperbola.